Okay, welcome to the exciting last day of class with your old pal Jim. Yeah, about the Rubik's Cubes, I need y'all to give those back to me. So I'm assuming that I will be back for the final exam in person. If we have to do the exam online, which I kind of doubt because I'm bouncing back pretty hard, I think, then I'll give you instructions on what to do with that. Does anybody have any questions first on the stuff? The last thing I left you with was that diagram where we kind of looked at what this last move did to the bottom. And I asked you to think about why basically that's enough for you to solve the cube. Anybody got any thoughts on that? Okay, so let's look at this. And let me show you something from the notes that might help you out too. Let me share the screen here. Hold on one sec. Right. Okay, so let me point out something in the notes here. If I can find the dang thing. There we go. This is the diagram that I left you all with last time. And the move there on the right, R prime, D prime, RD, RF prime, R prime, FD prime. If you look at that diagram, that's what it did. It swapped out the corner pieces C and D, changing the orientation of one but not the other. It swapped out the two side pieces, 11 and 12, changing the orientation of one and not the other. The side piece 9 set in place but got its orientation changed. 10 was left alone, and G was left alone, and H set in its place and spun to counterclockwise. Okay, so my claim is at this point that once you can get 2 rows, this is going to be everything that you need. So let me let's see here. Let me get a cube here that's got 2 rows here. Okay, so I'm going to take this cube here. I'm going to get 2 rows on it real quick. Hopefully really quick. And what I see when I've got this done with 2 rows is, I'm going to show you guys this. So here, my orange is the top. Notice that here I have yellow, blue, red. So it's geographically in place. And this was geographically in place as well. But these 2 right here are swapped. These 2 corners, they're bad. This one needs to go here and this one needs to go here, right? So what can I do, right? Well, if you look at the diagram, then basically to make these 2 corners swap, I just need to put them in the C and D position. Now this is, this is going to do some stuff to the cube as well, but if I do this move, trust me, I'm doing this move, then now what I get is I've swapped these out. So now geographically, if you look at all the corners, every one of them is in the right place. And some of them are a little bit screwy, but that's okay. So now what I try to do is I look at my sides here. Well, notice that this yellow one is cool, but the other 3 are off. I've got a green here, I've got a blue here, and I've got like a white here. So basically, I've got 3 sides, and my only goal here is to get those 3 sides geographically correct. Anybody got any ideas how I would do that using this move, given what that diagram says this does to the puzzle pieces?
If you use like the top, the matching corners as kind of like a pivot point, you can use the mirror and the regular operation to like swap out the sides that aren't matching with each other.
Okay, good, 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 good. Okay, so here's one thing that I need to do. Whatever move, and here he brought up the mirror image, and that's exactly right. What do you suppose the mirror does? What do you suppose the mirror image will do, that move that's kind of mirrored of this? What do you suppose it will do to block number 9? Anybody want to take a guess?
What exactly do we mean by the mirrored image?
Well, so if you look at the cube from the front, right, then the original move does right prime, right? The mirror image, the first move is left clockwise, right? Notice the second move in the original is down counterclockwise, and the other one is down. So it's sort of the opposite of it. And what it'll do,
yes.
And what it does is it will swap out those two corners the same. So it'll swap C and D, but it'll do the orientation in the opposite direction. And the mirror image will leave 12 alone, just like this one left 10 alone, but it'll swap out 11 and 10, changing the orientation of 10. And it will also rotate G instead of H, and it'll do it clockwise, right? Now, what I want to do is I want to swap out those 3 pieces. Now, geographically, what I need to do, if you look at the bottom of my cube, this is the piece that's correct. And what I have to do is I have to take this green guy all the way across here. So it has to go here. I have to take the white, this one down here, and this one here. So I need to go in a cycle like that, right? So what can I do? Notice if I do the original move, it will take, the original move will take this green piece here, or this piece right here, and let's see, from my perspective, yeah. So it's going to go down here. I know it looks my camera's in reverse. I'm sorry about that. But the original move takes this way, and then the other move, the mirror image, does it this way. So if I do, excuse me, if I do the original move with starting with the R prime, and then I do the mirror image. And the reason I have to do it in tandem is, remember, I have to also fix the corners, right? So I have to do this in multiples of 2. I have to do an even number, grand total of moves in their mirror image to make sure that, because every time I do one of these, it swaps the corners. And I've got to do it again to make it swap back. But I've done the move now, and you can see what's happened is my yellow still geographically correct, but now all my other ones are as well, right? So now at this point on this cube is actually geographically solved, right? Now I've got to orient everything on the bottom. Oh my gosh. Any ideas on, look at that bottom, right? The first thing I'm going to try to do on the bottom is orient the sides. Orient the side pieces. This is going to have to be a 2-step process. Anybody see what I can do to orient the sides?
If you repeat either the regular or the mirror operation twice, then it should preserve the locations while rotating the side pieces, right?
Right. What we have to do, and Connor, you pointed out a very good thing. What we have to do is we have to keep the fact going that this is geographically solved, right? We don't want to mess up the locations of everything. So notice that if I do either the move or its mirror image twice in a row, then it will preserve the geographic bit, right? Because it swaps the two corners C and D, and it swaps the two sides 11 and 12, and then it swaps it back. But what's going to happen to these two side pieces on the bottom, 11 and 12? Well, it's actually going to change. So if I do it this way, what will happen is these will swap and then swap back. And when it does it twice, it'll change the orientations of both. Let's try that. So I'm going to do the move, and then I'm going to do it again. And let's look at the bottom of the cube. And that's exactly what's happened. It's changed the orientations. And so now these two are correctly oriented. And now I would like to do the same thing here. Swap these both out and reorient them. So making this my front, I do this twice again.
Wait, just to clarify, you're doing the move twice in a row and then the mirror twice in a row?
No, just the move twice in a row is all I got to do.
Oh, but like total, you're doing each one twice in a row, not like one once, then the other, then the move, then the other.
No, that's right. So when I say move, I mean R prime, D prime, RD, that one. I just did that twice in a row.
Okay, thank you.
And let's see what we get. Well, we get sort of what I was hoping for. Notice that my bottom is oriented correctly. So everything's geographically correct, and the sides are all oriented correctly. But now I've got these pesky corners. Let me ask you this. Take a minute and ask yourself this. Take the move here, look at that diagram. Tell me what happens when I do the move 4 times in a row. The right prime, down prime, right down. What happens when I do that 4 times in a row? Okay. What do y'all think? What happens if I do that schematic diagram 4 times in a row? Where do I come up?
Does the top right corner orientation change, like C in this case? Does the orientation change by 1?
Yeah. Okay, so that's right. I think that's right. So let's go through this. Let's go through this block by block. Let's start with 9. Okay. What happens if I do that 4 times in a row?
Is it just going to go back to the way it is currently?
That's right. Plus 0, plus 0. So it'll be back to the way it is currently. What happens with 11 and 12? Well, every 2 times they're oriented plus, and another 2 times back. So 4 times in a row. So 4 times in a row leaves all the side pieces in their position and oriented the same way, correct? Mm-hmm. So that means that if I do it 4 times in a row, I'm not going to mess up this nice cross I've got. Everybody okay with that? Any questions on that? Okay, next question. What happens to H? What happens to the block H if I do this 4 times in a row?
Does it have an orientation of, like, it goes from, like, the orientation changes? I'm just not sure how to verbalize it. Like, I know you go, if you start at 0, for example, then, or if you I don't know, if you start at 2, then you go to 1, then you go to 0, then you go to 2, then you go to 1.
There you go. There you go. There you go. So when you do it, so you start off with clean slate. First move goes orientation 2. Second move, another 2, which is really 1. Third move, 3, which is 0. Fourth move, back to 2, right? Another way to think of this is doing this move rotates that counterclockwise. Doing it thrice rotates it back, and then once again takes it back to counterclockwise. Agreed?
So it's really just, it's whatever orientation it starts off as plus 2.
That's correct. So in other words, it will turn it counterclockwise. What about D? Where does that end up if you do it 4 times? Well, I think a good benchmark is, since every time it flops it out with C, if you do that 4 times, it'll end up back at D. So geographically, it should be okay. But what about the orientation?
Does the orientation stay the same?
Well, let's go through it. So we've got 4 things to go through. D goes to C's position with a +1 orientation, right? That's first move. Then in the second move, it kicks it back to the original place D, and it's still +1, because in the first move it kicks it up 1, and the second move it's 0, so it leaves it alone. So we're still to +1, right? So now D is back in its place with a +1. Third move, it kicks it back to C, but now it kicks it up another 1. So now we're at +2. And then that's the third move. And in the fourth move, it kicks it back to D with a +2. Everybody okay with that? And C, what happens to C? In the first move, C kicks over to D's position and is left alone. Second move, it's kicked back to its original position at C with a +1 orientation. Third move, it's kicked back to D, no change. Fourth move, kicked back to D with a +2 orientation. So in other words, what happens if you do this 4 times in a row is it should be something like this. Oops. Yeah, okay. Oh, I don't even have touch screen, dang it. Yeah, you'll have to pardon I don't have my good computer, so. Yeah. Yeah, this is. So at the end of the day, all 4 sides were left alone. And these 3 were like that. That's what happens on the left if you do the original move 4 times in a row. What do you suppose will happen to the mirror image? What do you suppose the mirror image is going to look like? If you do the mirror image 4 times in a row, what do you think the mirror of that is?
Would it just be the top 2? Our top 2 corners are also 2 and 2, and it would be the bottom right that is 2?
Very close.
Oh, well, if you did the reverse from scratch, would that be the case?
How do you mean from scratch?
As in, like, it starts out at orientation 0?
Oh no. So what effectively what happens is if you do the first move 4 times in a row, it rotates the bottom left, the top left, and the top right 2, which is counterclockwise.
Mm-hmm.
If you do the mirror image 4 times in a row, it rotates the top left, the top right, and the bottom right 1 in the mirror image of counterclockwise, which is clockwise. So I'll look at this right here, and this is really kind of a mess. Let me figure out what I want to do. I'm going to start off with doing counterclockwise, counter, counter, counter. And sometimes I screw this up, but I think I'm going to get this right this time. So if I apply this, I predict that it's going to turn this counterclockwise, and this counterclockwise. So I'm going to do the original move to this 4 times in a row. Once, twice, 3 times, and 4 times. And this is what I get. And this should be fixable because this, I need to rotate this. To fix this, I need to rotate this down here, the red down here, and the red down here. That's 3 counterclockwises. So all I have to do is apply this one more time to this. And I should be there. 9, 8, 7, 6, 5, 4, 3, 2, 1. And there you go. So this move actually will get you anything you want. Once you get so the first move gives you well, the one that we previously did allows you to get 2 rows. And once you do that, applications of this other move will get anything you want. Now I'll do one kind of from ground zero here. Let me share a screen here with the notes. So I'll go through the complete solution of one of these. Let me see if you guys can see a little bit better here. I wonder if this will be better. Maybe the color's short. All right, maybe the colors. All right, so I've got some scrambled cube. And of course, the first thing that I asked you to sort of figure out on your own was how to just get one side. And so hopefully you guys at least can get a little bit of that. So let me get one side here. And see, where are you? There you are. Okay, so now we have one side, the red, and I've got all the colors right here. So what I'm going to have to do is I'm going to have to first get 2 rows. And let's see what I've got here. My bottom color here is orange. And so nothing that's orange is going to belong up here, right? So I can, all these oranges are kind of junky. But here is a green white, and that belongs up on the second row. So I align it up here, and this one is actually the mirror image, down, front, down prime, front prime, etc. And that moves my green white up there. Let's see what else I've got going on down here. Now I've got a green yellow. It goes right here. So now I've got this. I don't have anything bad happening to me, but let me do this. What if what happens if I encounter this? See what I've got here? I've got the blue white, and it's put in the wrong way. What effectively do you think I need to do here? Well, there's nothing too big, really. I mean, you got to get it out, right? So I'm going to put something up here that doesn't belong but at least it gets that non-oriented piece out. And now it's floating around somewhere on the bottom. Here it is. Here's my offender. And now I can put it back correctly. This one requires the original move, the one that starts with down prime. And now I guess I've almost got the second row, except I need to put this yellow blue in there, and that again requires the original. I only had to use one mirror image there. Now I have my 2-row arrangement here, right? So I'm going to go through, being mindful of this diagram down here. I am going to go through and try to fix stuff. And the first thing I do is I'll look for a pair of the same color in order. You can always find one of these. Here are 2 whites, for example. It doesn't matter. I'm going to line them up where they go. And I see that this is white, green, orange. So it's in the wrong place. So these 2 need to be swapped for sure. So I'm just going to not put much thought into it. I'm just going to do this move here that swaps C and D just to get that fixed. Okay. So now I've got these white ones. Now I've spun them around, and they're in their correct place. Let's check the back side. And in the back side, these I got lucky because these are already in their correct spot. But if they hadn't been, I would have just done this with these 2 at the front to fix them. So now at this point, I am geographically correct again. So in my next step, I'm going to try to orient the sides correctly. And this one, I'm glad it turned out this way because this is kind of the crappiest one. If you look down here, nothing's right. Nothing is right. So we got this, it's all wrong. And so what you should do at this point is you don't want to mess up the fact that the side or the corner is geographically correct. So just actually just do a right and a left. Actually, it really doesn't matter what you do because all you really need to do is scramble those bottoms using using the move in its mirror. And once I've done this, I'm still geographically correct on the corners, but one of these is now correct, right? And that is the blue orange one is correct. The other ones aren't. Now, what I need to do is I need to navigate this white across to where it belongs here, because this is white orange. It needs to go over here, and this one needs to come down here, and this one, of course, needs to go up here. So that means that to get this to go across, I'll start with the move, and then I'll do its mirror here, and that makes it step across. And now, if you look, the cube is now geographically correct for both the corners and the sides. Everything is in its correct position. It's just some of these are kind of oriented wrong. And what I have is these two are good to go. They're okay. These two need a little help, right? And so if I do the move twice in a row, it's going to swap these and swap them back with the orientation change. And let's try that here. And there we go. So now the sides are we're done with the sides, and it's just about orienting the corners. Now in the corner orientation, notice if I turn that clockwise and that clockwise, one will be correct, and then I can finish it. So, or I'm sorry, not clockwise, counterclockwise. So I'm going to do the regular move, and it's going to turn those three counterclockwise. And effectively, it's going to fix one and leave the other three unsolved or unoriented like this. But see, now I can do another one to get those three oriented correctly. And again, I need to turn this counterclockwise. So I should be good to go. You can play around with this in any situation that you're going to encounter. You can solve the cube. Obviously, we don't have time to see every situation, but for example, when I got to kind of the end game, I had 4 corners out of place in the last 2 examples. That means 2 of them need to be oriented clockwise and 2 of them need to be oriented counterclockwise, right? Because remember, all the orientations have to come, it has to be a zero-sum game on the orientations, right? What else could you see? You could see 2 corners, wrong, one being rotated counterclockwise and the other being rotated clockwise. That's something else you could see. So here's what you can see on the bottom after you've oriented the sides. You can see 3 corners wrong, in which case you'll have to do this move 4 times. Or you can see 2 corners wrong, one of them clockwise, one of them counterclockwise, out of sync. And then you'll have to fix that, and then you'll have to rotate it so that you get 3 out, and then do that move again. Or like we saw, we can have 4 corners got wrong, which is 2 clockwise and 2 counterclockwise. And it's the same strategy as 2 out as well. And of course, you could also see all corners correct if you're lucky. Okay, any questions on that? Do you all understand how this works in the implementation? Let me give you an open question as well. I have never worked this out. I always think I'm going to, and then I just, life comes along and I've got other things to work on. But it may be the case, I don't know, it may be the case that this previous move, remember the move here that we had just to get the second layer correct, it may be the case that you can solve the entire cube only with this move. And so what you would have to do is see how you could implement this move. Now, again, this move does, let me show you what I mean. Let's look at the cube, and I'll leave you with the open question. So let's suppose this is a solved cube, but let's take this piece and move it up here. And so now, if you see, what I've got is I've just got this one piece wrong, and now I'm going to put it back using the mirror image of that move. And now I've got 2 rows, just like I had before, and the bottom is scrambled. And what's happened to the bottom? Well, we have a mess that's happened to the bottom. I mean, these 2 used to be over here. These 2 used to be over here. And you got a big swap. This one's still in place with the orientation. This one's in place with the orientation's wrong. These 2 are swapped with the orientation still 0. This move on the cube, moving things around like that, might be enough to solve the cube. But I've never checked it out. So maybe you only just need the 1 move. It'll probably be longer to solve the cube using this, would be my guess. But I've never figured it out. So that's something else you can do. You can also use this technique for a couple of things. Number one, you can use it to make shortcuts. If you decide you want to like quit school and become a speed cuber for a living, you can use this to do all kinds of little shortcuts. And also this technique will work with any size Rubik's Cube, any size Rubik's Cube. And it'll work with the other kind of puzzles that you see as well that they sell. Okay, any questions on this?
What kind of questions regarding this material like would we see on an exam?
I haven't critically thought about this. I mean, I'm not going to hand you a cube during the exam and say solve it. I would probably ask you mathematical questions about it. I haven't thought critically about the exam yet, but I might ask you some basic understanding things about the cube, right? What kind of thing might I ask?
Like even and odd permutations?
Yeah, something like that, right? Or I might ask you, something like, what do you know about the orientations of the corners? When you add them up, they sum to a multiple of 3, things like that.
Okay, but like we won't necessarily have to memorize exact moves or.
Oh, no. Now, if I gave you some moves and gave you a diagram, I would expect you to be able to do that computation.
But right, but we don't necessarily have to like memorize that diagram or anything.
No, you don't have to be able to solve the cube or memorize these moves or anything like that. No, none of that.
Okay, thank you.
Okay, any other questions on the homework or anything like that? Hey, let me remind you folks, please, I will be at the math end tomorrow. I will not be there giving you my cooties, but I will be online all day. If you all are there, that'd be great. The review session will be at 6 p.m. On Wednesday. I am assuming right now that it will be live in long 216. Of course, there will always be the Zoom option no matter what. If I have to revert this to online, I will certainly let you know. And if I am there, I will be wearing a mask, right? If we do it, so if that's helpful for you. Any other questions?
This one, I guess it's kind of not as serious of a question, but do you have any recommendations for deriving permutations? For like, not specifically just for like Rubik's Cubes, but like if we were to apply this to other tasks and things, because I know you said you worked them out by hand on paper, but did you just like, was there some amount of trial and error, or?
There was a little bit of trial and error to it. And after you start messing around with it, you start to see patterns. But, with the Rubik's Cube, there's really only 6 sides to turn, and clockwise or counterclockwise. And really, you can rule out most of the sides anyway, right? I mean, with most of my moves, if you notice, with most of those moves, we used front, left, right, and down. I mean, we really only used 4 sides, and you can kind of get wherever you want just by turning the cube. But yeah, as far as the permutations, you think about where you want your elements to go. You think about, in particular, what I did when I did this with pencil and piece of paper is I tried to build things that would leave alone what I had already solved, right? So in particular, when I tried to get the second layer, I looked at stuff that left alone the top 4 corners and the top 4 sides. And I found a reasonably short one that made the bottom 2 rows dance, which is exactly what I wanted. And then I analyzed it and said, oh yeah, so now I can do this. I can get the second layer. And then I did another computation and said, okay, what can I do now? And I wanted to accomplish 2 things. I wanted to come up with a permutation that left the top 4 corners, the top 4 sides, and the middle 4 sides alone, right? So it stabilized all that. And then I didn't care what it did to the bottom 4 corners and the bottom 4 sides. and I figured out something that left everything alone, and I analyzed what it did to the bottom, and I said, okay, this is good enough. This will solve the cube.
Okay. So if we were to like go and look at other possible operations that preserve the top two layers, assuming that there are other possible operations that preserve
Oh,
the two top
I
layers,
promise you, there's a lot of them. Yeah.
then we could possibly find ones that may even take fewer moves based on.
Oh, yeah. Look, I will be the first to tell you that there's plenty of ways to one-up me on this particular algorithm that I've given you. Because the advantage to what I've done, like the speed cubers, the people that are really good and the ones you see on TV that are like, do it in seconds or whatever, they know a lot of moves. The difference is I understand the moves, right? I mean, I didn't, nobody gave me these moves and stuff. And once I had enough to do it, then, I kind of like, okay, that's enough. So basically I have one move to get the second layer, and I have one move to fix the bottom, right? And with each of those comes a mirror. So there's really only two moves that I do. Now, the consequence of this is it's super not efficient with regard to being a speed cuber. For example, when I got down to that place where there were four corners left, right? So everything was right, except I needed to orient those last four corners. When I've got four corners or two corners out of place, with my algorithm, that is 72 moves from solving. And yeah, so even after I've done all that stuff and I get down and I've got four corners that are oriented out of place or two corners that are oriented out of place, it's 72 moves. And I can go pretty quickly on that, right? But I mean, it's still 72 moves. So I'm not going to win any contests. If you give me a cube that's just, right out of scrambled at random, it's probably not going to take me 2 minutes to do. And in fact, I'm usually between 130 and 140. I have been under a minute, but to get under a minute, I got to get lucky, right? So things got to happen for me to go that quickly. And so the upshot is you can knock yourself out. I mean, you can find all kinds of neat little shortcuts. I had a student at NDSU many years ago who actually gave a talk after he had this class with me. He gave a talk on a technique that he came up using, like conjugation, which is something you learn in group theory, to make up moves on the fly. And he was really, really fast. I mean, he could do it in an average of about 30 to 45 seconds. So yeah, the world's your oyster. There's lots of good stuff out there. Okay. And I'll give you one more bit of perspective. When I've got four corners, when I've got it all solved geographically, and there's four corners rotated out of position, then I'm 72 moves away from solving it. And like I say, I can make that go pretty fast, but it's still 72 moves, because no matter where you are on the Rubik's Cube, if you count a 90-degree turn as a move, you are never, ever more than 26 moves from solving the cube. But finding that shortest path is more difficult than knowing some shortcuts and trying to do it with extra steps to go quickly.
So wait, why is it again? Because I remember you mentioned that when we first started the section on Rubik's Cubes. How is it that we know that it only takes 26 moves minimum?
Because somebody proved it. And surprisingly, it took a long time. I mean, this is a fairly recent result. I think it's probably only like maybe 15 or 20 years old. It took people working on this. And this is just a single group on a freaking toy, right? And it took a long time for them to find it out. If you see it on the literature, I think they say it's 20 moves. But I think that 20 sort of sometimes counts these double moves, like a single move is turning two. And if you don't count that, I think if it's only 90-degree turns, I think it's 26.
Oh, okay.
Yeah, and in fact, I think they call that God's number or something crazy like that. But anyway, it took a long time for them to show that. Okay. Any other questions for now? Okay, listen, folks, remember to bring your Rubik's Cube to the final. If we don't have the final in person for whatever reason, then I will give you instructions on what to do with them. And also, I'll tell you what I always say, once my student, always my student. So if I can be of help to any of you in the future, please let me know. Don't forget to do your evaluations, and don't forget to do the, don't forget to do your assessment and mine. Don't forget to do the course evaluations as well, because if I get 90%, everybody gets an extra quiz score of 100. So any other questions on that?
I just have a question about the math end. I know you said you will be online.
Yes.
If we like only have a question for you, do we have to go to the math end in person, or is there a link?
No. You know what? I need to. You know, I never gave you all the URL for the math end. I'll send that to you. I'll send you the URL so you can get on and you can go virtually. You certainly can go live and find out how to do it, or you can ask other questions. I'm probably the best source for questions in this class. I will send you all the URL for the math end, and you should be able to get on there.
Okay, thank you.
You're welcome. Anything else?
Are you gonna have office hours today?
Yes. Online, of course. Any others? Yes. Oh, and I'm glad you asked that. Office hours. My office hours will be my regular office hours during finals week, including my class time. So it'll basically, I guess it'll be 7 to 2, something like that, on Monday and Wednesday. Others? Okay, well, don't forget any of that stuff. Y'all rock on. Hopefully I'll see you at the math end tomorrow at the review session. And other than that, have a good one, and we'll see you all next time.
Thank you.
Thank you.
You're welcome.
Thank you.